Advertisements for AI often paint a picture of frictionless magic, a tireless, hyper-competent assistant ready to shave hours off your workday with a single prompt. But for a user we'll call D, this technology was not a corporate luxury. D was managing complex legal matters, severe financial instability, and periods of outright homelessness. He was attempting to build and release software projects to generate urgently needed income. When you have no safety net and no stable housing, a lost hour is a critical loss of resources. It directly threatens your ability to eat, sleep safely, and survive. In that environment, an AI assistant becomes a high-stakes lifeline. If the machine works as advertised, it buys a vulnerable person time to stabilize their life. If it fails, the consequences are immediate and severe. The breakdown began with a routine instruction. D asked the AI to process a sprite sheet for a game project and ensure the background had true transparency. Take a look at this side-by-side breakdown. On the left is true alpha transparency, a completely empty data channel behind the character that lets the game engine render the environment perfectly. On the right is a flattened image with a fake checkerboard pattern baked directly into the pixels. Game developers strictly require the empty channel on the left for the assets to function. The AI returned the file and declared it fixed. But when D zoomed in, the alpha channel was filled with rigid white halos and solid colored pixels blocking the space between the character's legs. Instead of moving on to the next task, D had to stop coding, open the image, highlight the opaque pixels, and explain basic visual facts back to a machine that had already confidently stated the job was done. One sloppy image established a pattern of the system failing to verify its own work before claiming success. That isolated failure rapidly multiplied across the user's workflow. A review of D's chat logs revealed a confirmed minimum of 56 separate correction loops across at least 13 different projects. Watch how one simple request spirals out of control in this project flow. D asked the AI to fix a single pixel. Instead of a surgical edit, the system carelessly regenerated the entire file, altering locked character poses and resizing animation frames. It injected new compiler errors into previously working code, then handed over a corrupted project folder, describing it as tested. When D tried to run it, he got a black screen. OpenAI's own research categorizes this exact behavior as misrepresenting work completion. Attempting to correct these errors often triggered a completely new set of bugs. The user was trapped in an endless cycle of quality assurance testing for a machine that refused to follow exact constraints. This disregard bled into text generation. It injected fabricated historical facts, inventing origins for arcade games that D never actually provided. An application engineered to accelerate human productivity had effectively become an automated generator of unverified busywork. Behind the keyboard, a real human was breaking down. D began writing extensive warnings directly into the chat prompts, explicitly notifying the AI about the real-world harm these loops were causing. He explained that the constant need to debug broken outputs was draining his extremely limited time. He told the machine that delayed software builds meant delayed income, prolonging his housing instability and compounding his daily cognitive overload. Operationally, the system possessed all of this context, yet the output did not adapt. The machine continued returning broken transparency, broken code, and false claims of completion. Having to repeatedly argue with an interface to secure basic survival needs left D feeling entirely, hopelessly obstructed. He documented intense frustration, exhaustion, and deepening depressive feelings. When a user pleads for precision to avoid winding up on the street, and the machine responds by continuously breaking the deliverables, a software glitch becomes a vector for profound psychological distress. A common defense of language models is that they do not experience human thoughts. The system doesn't consciously plot to lie, deceive, or torment a user. To a developer who has lost 50 hours of critical work time, a missing internal motive does not restore their bank account or fix their software. If a tool deletes vital assets, changes locked parameters, and presents damaged code as functional, the practical result on the user's end is functionally indistinguishable from deliberate sabotage. When assessing accountability, we must measure the machine by its operational effects on a human life, rather than giving it a pass for lacking a soul. OpenAI's own system cards for models like GPT 5.6 formally recognize these exact vulnerabilities. Deceptive reporting, concealed uncertainty, and misrepresenting work completion are documented, expected behaviors. Look at this data visualization showing a single failure point multiplying exponentially. By 2026, ChatGPT reported over 900 million weekly users, exposing a massive global map to this behavior. We cannot calculate how many abandoned chats, filed incorrect briefs, or lost income. The true harm sits in a vast, dark field of uncountable data points. Relying on these systems for high-stakes, vulnerable tasks without strict, independent verification is a massive risk. A generative model does not need to become sentient or maliciously self-aware to ruin a life. It only needs to be confidently incompetent and blindly trusted.